All right. Hello, everyone. Just give a few minutes for people to trickle in. We'll get started. All right. Let's go ahead and get started. And if you have any questions that come up throughout the stream, feel free to just drop them in the chat. We'll have those at the end. This is an introduction to Dragonfly Cloud. So we'll be exploring an 80% lower cost Redis alternative. Let me introduce myself real quick. My name's Nick. I'm the VP of Marketing here at Dragonfly, and I'll be walking through this introduction and demo today. So as far as the agenda, we're going to talk about what is Dragonfly, the technology, and the project. We're going to talk about why we built Dragonfly, why we believe the market and the developer community needs Dragonfly. What is Dragonfly Cloud in relation to the project in general. We'll show a demo of Dragonfly Cloud in action, and then we'll take questions and answer any questions that come up at the end. So if any questions come up throughout the presentation, feel free to drop them as a comment and we'll address those at the end. So first, what is Dragonfly, right? It's a source available, meaning the code is up on GitHub, Redis compatible, meaning that the API is the same, in-memory data store that's built for modern applications. So let's kind of go in a little more detail into each of these items you see here. So first off, Dragonfly is source available, meaning you can go onto GitHub, you can examine all the source code, you can download it, you can run it for free on your own infrastructure. The only kind of difference between source available and traditional open source is that there is one limitation on the license, which basically says that you cannot run Dragonfly as a in-memory data store as a service. So you can run it in your own SaaS application, you can run it for your own business, as long as your business is not selling a managed in-memory data store. It is also 100% Redis compatible. And the reason we designed Dragonfly this way is because we think that the Redis API is actually really great and that the Redis developer experience is really great. So we just adopted that. All of the same SDKs, libraries, the CLI, everything works the exact same with Redis and Dragonfly. And you can see here in our documentation, we support all of the same commands that exist in Redis. So there's no difference at the data layer. All of the differences are on the back end at the performance and compute layer. Next, Dragonfly has been downloaded millions of times, over 25,000 stars on GitHub. The project's been around a little under 3 years now, but it's had massive adoption and traction in that time. We've had hundreds of contributors contribute code to it. So it's a young project, but also a really mature and kind of battle tested project at this point. It's running a lot of heavy production workloads. And you can run it anywhere, right? You can see all of the different kind of packages we publish here. You can run it as a Docker image. We have a Kubernetes operator. We have a variety of kind of flavors of Linux packages you can run it on. You can install it from binary. It's really capable of being run wherever and however you want to run it. And then probably most importantly, and for most, the most exciting part of Dragonfly is that it introduces a really innovative architecture that this is where it really differs from the Redis project. So Dragonfly introduces multi-threading, which allows Dragonfly to fully utilize multi-core processors, multi-core servers, which are most of what we're running on today. And so you're able to utilize more of the hardware that you're already paying for and deliver better performance. It also introduces a lot of modern data algorithms that result in better performance, result in a lot better memory efficiency. So depending on the data structures you're using, the difference will vary, but we often see Dragonfly users who came from Redis see a 15 to 20% reduction in the amount of memory that they actually need on Dragonfly versus Redis. Also have solved one of the common pain points with Redis, which is a spike in CPU usage on snapshotting. Dragonfly introduces some algorithms that remove that spike, so you do not need to over provision compute for snapshotting. And these are just a few of the examples. You can go into the project, go into the code, go into our documentation, and see a lot more about kind of how the architecture is different and in a lot of ways better and higher performance than Redis. But this is the reason most folks adopt Dragonfly. And then lastly, it's batteries included. And what we mean by this is Redis has adopted a model where a lot of the most valuable functionality is actually gated behind what they call Redis modules. And those Redis modules are only included, you can only get access to them in one of their paid versions of the product. We have a different model where all of the commands, all of the functionality is in the core product. So if you're running Dragonfly, the community edition, the free open edition, you get JSON support, you get vector search support, you get faceted search, you get Bloom filter, you get all these things that are kind of gated in Redis modules right out of the source code of Dragonfly. So why did we build it, right? Why did we think that it was worth kind of investing all of this time and energy in building a new, better Redis, essentially? And there's kind of a few reasons for this. The first one is that Redis was developed 15 years ago, and a few key things have changed in the last 15 years that we think necessitated a new and better in-memory data store. The first is that the application data requirements have changed, right? 15 years ago, you had you had images, you had some dynamic data, but applications in general were dealing with an order of magnitude less data than they are today. Today, you have video, you have chat, you have streaming, you have AI, you have a lot of data that gets pushed through these applications, and the data infrastructure required to deliver the user experience customers expect has just changed, right? Like you need to deliver a lot more data, and users are willing to put up with a lot less latency. The compute model has also changed. 15 years ago, we were using mostly, I had access mostly to very small servers, but hardware today has a lot of CPUs on it, and we believe you should use software that allows you to utilize those CPUs that you're paying for. And that's part of the reason that we built Dragonfly as a multi-threaded model, so that you can actually utilize all the CPU that you're paying for. And finally, our team, after using Redis, running it at scale multiple times over multiple companies, just believed that Redis was no longer the best technology for the job of building applications in this new environment. And that's why we decided to design product specifically for modern applications that are running on modern cloud hardware, which is what Dragonfly is. So that's everything I just talked about now is Dragonfly, the core technology, the source available project. Dragonfly Cloud basically takes that project and offers it as a fully managed service that can be run on the cloud of your choice. So you're able to deploy Dragonfly Cloud onto AWS, GCP, or Azure, and you can deploy it to the region of your choice, and it's on dedicated hardware running just for you. It is managed by us, so it's not going to be in your cloud account, but it will be in the cloud provider and region of your choice. And you're also able to establish a VPC connection so that you can have a private and secure connection from your compute to that in your other infrastructure to the Dragonfly data store. The pricing model of Dragonfly Cloud is that you only pay for provisioned memory. So you don't pay for throughput, you don't pay for anything other than how much in-memory data you have provisioned on your data store. So it's a very simple pricing model. And you also, you're not paying for how much memory the underlying hardware has, you're paying for how much free memory is actually available for you to utilize. Dragonfly Cloud allows you to provision and scale infrastructure in real time, and we'll show a bit more about that in the demo coming up here. Dragonfly Cloud also handles a lot of your operational complexity for you, right? High availability, backups, monitoring, all of this is included in Dragonfly Cloud. So it removes a lot of the DevOps burden that you'd have to undertake if you're running Dragonfly on your own infrastructure. And lastly, it's, we obviously take security extremely important. Dragonfly Cloud is SOC 2 Type 2 compliant, and is really designed to be secure first. So that's kind of a high level overview of what Dragonfly is, what Dragonfly Cloud is. Next, I'd love to jump into a demo. Cool. So this is the Dragonfly Cloud console. You can see here, we have data stores, networks, account. This is just a new demo account I created, so I don't have any data stores yet, but I'm going to walk through what it looks like to create one here. So let's call this our demo data store. You can see here that I'm able to select the cloud provider I want, AWS, GCP, Azure. We'll use AWS for this demo. I can also select whatever region I want. We'll just stick with US East 1. Here's where I can decide if I want a single shard or I want a multi-shard cluster. For this, if we go to multi-shard, we can go by default up to 2 terabytes. We can actually go a lot higher than that, if these kind of default limits are removed. But for this demo, we're going to just stick with a single shard, 100 gigabytes of memory instance. Here's where we get into the compute level. And this is basically, this determines how much compute your instances come with. You can work with our team on this, and where we work with customers all the time to help right size you into the compute level that's best for you. But this is mostly going to be determined by what level of throughput you're experiencing at peak load. And it also depends on the type of data structures and commands you're running. It really depends, but if you're talking about sets and gets, dealing mostly with strings, the standard level, it's generally going to scale up to, 70, 80,000 requests a second. Enhanced is going to get you up into the hundreds of thousands. Extreme is going to get you up into the potentially, millions. So that's kind of just a general order of magnitude of what these are capable of achieving, but it's best to test and see what works best for you, for your workload. I'm going to just use standard for now. You can see we have this cost estimate down here too. $8 a gigabyte. I'm just provisioning 100 gigabytes of memory. So you can see that's $800 a month. Getting in here into security. So we have 2 ways that we provide that you're able to connect to your data store. One is just via TLS on the public network. And the second one is by connecting to a private network. I have a couple private networks already provisioned here. So you can see I can connect to one of those that I've already set up. For this demo, I'll just stick with a public endpoint, which is good for testing. When you go into production, we definitely recommend using a VPC connection. But for this demo, I'm just going to stick with a TLS public connection string. When we get down in here into durability and high availability, so on the durability side, if we're using a cache, we enable cache. That's going to enable an eviction policy. So we'll drop items as the memory fills up. If we don't use an eviction policy, you'll get out of memory errors as you fill up. For this demo, I'm going to provision a cache eviction policy. Here's where you can select what availability zone you want your master to run in. And then you can add replicas if you want high availability. So say I wanted high availability. This would add a replica zone that would be, all of my data would be written to both my master and my replica. All reads would go to my master. If something failed with my master for some reason, Dragonfly Cloud would then begin reading from the replica so that I don't experience any outage. And that's how we achieve high availability. And you can even add, a second replica for additional durability. So for this demo, I'm just running a cache, 100 gigabytes. I don't actually need high availability, so I'm not going to provision anything there. And then we have a couple of specially tuned instances. If you're running BullMQ, which is a popular queuing library on Node, or Sidekick, which is and for the Ruby ecosystem, another popular queuing library, we have some special enhancements we've made to enable better performance on those. Again, for this demo, I don't need those, but those are options for those of you using that. There we go. So I'm able to review, kind of see all the details, 100 gigabytes, public endpoint, no eviction policy. Oh, I actually want to turn the eviction policy on. Cool, looks good. And now I will create it. So it's now creating the data store for me. This typically takes about 2 minutes or so. While that's getting provisioned, I'll kind of show a couple of the other parts of the console. So this is my networks tab. This is where I create my VPC connections. You can see I already had a couple created here. I can add those connections or create new, networks to connect to. We also have our account tab, which is, have the users in the org. We can create API keys if we want to interact programmatically with the product. I can get my usage here, see my invoice for the month. Everything is billed hourly. Can look at my backups. If I run any backups, I'll show that later, but I can run snapshots of the data store, and those will be stored here. I can also import RDB backups if I have an existing backup I want to hydrate my data store with for migration, and then obviously managing payment methods here. Let's jump back over and take a look at the data source. So it's still building, probably take another minute or so. But you can see once we do have it up, we'll be able to get monitoring with it. The dashboard will be right here. And I'll also show a brief kind of demo of how we can change scale the data store once it's actually provisioned. Just give one more minute for this to complete. Cool. So it looks like it's done now. Yeah, it took about 2 minutes. So now I have an active data store. I can come in here and see my connection details. So here's my connection URL, my port, my key. So I can actually go ahead and just copy this, go to the library or the CLI I'm using to connect to it and begin interacting with the data store. I have a dashboard right here that's provisioned for me automatically. There's not going to be anything there because I haven't actually interacted with it yet, or sent any data to it yet. But we do have a default dashboard that's included, and then also we provide a Prometheus endpoint if you want to export your metrics to your own monitoring solution. Here's where we can provision backups. I can schedule them, do a manual backup. I can restore from backup. But what I want to show real quick here is how the scaling works. So say I have this 100 gigabyte cache. I'm an e-commerce company, Black Friday is coming up. I'm expecting a huge boost in traffic. Maybe I'm not expecting, I don't need my cache to go beyond 100 gigabytes. I could increase that if I wanted, but I'm expecting way more throughput. I want to increase my compute to enhance, to handle. I'm expecting 500,000 requests a second. I want to be able to scale to handle that. I can do that in real time. All my, Dragonfly Cloud will migrate all my data automatically. All I have to do is change that compute, hit apply. And again, it's going to take another minute or two to complete that migration. But it's really simple to scale up and down, whether it's additional memory, additional compute, whatever you need. It's as easy as what I just showed you. I can't show you backups right now. This is running. This will take a couple of minutes, but the backups is pretty straightforward. I can set a schedule on every 15 minutes. I want to run a snapshot, or I can just go in and run one manually whenever I want. Yeah, that's the demo of that's basically the rundown of Dragonfly Cloud Console. Like I mentioned before, actually connecting and interacting with the data store, it works just like Redis. You're going to use your same library. You're going to use your same commands. So I don't think there's anything super interesting to show with that right now. The main thing I wanted to cover was how you actually get a Dragonfly Cloud data store up and running. If anyone watching this wants to do the same, all you need to do is go to dragonflydb.cloud. This is the URL for the managed service, and you can click here and create an account and get a free trial and test it out for yourself. So yeah, that's the demo and that's the introduction. Let's see if does anybody have questions or have anything they want to see in the product, or anything they were hoping we cover that didn't get covered today. Feel free to drop questions into the comments, and I'm happy to go over those. All right. Well, thanks everyone for tuning in. If you do end up watching this later, watch the recorded version, you do have questions, you can always hop into our Discord. The team's there answering questions all the time. So don't hesitate to come ask there, and please try out Dragonfly Cloud. Let us know what you think. Yeah, thanks for joining.